Okay, so first of all, this is a review of what we did yesterday. Yesterday was 12.1 about radians. We're doing day 2 of radians today, where just kind of showing you the future here. I'm going to be asking you, like, where is 7 pi over 6? And right now I get that would be very intimidating. Be like, well, I don't know exactly where that is. But by later today, you'll be able to say, oh, well, 6 pi over 6 is right here, so 7 pi over 6 must be just another little wedge further. So it's like there. That angle right there, starting from here, that angle would be 7 pi over 6. But again, I'll teach you how to do that kind of stuff, and also about negative angles. And then the last thing is stoichiometry, which I know you already know, but you aren't going to be having simple ones like change 20 meters per second into miles per hour. It'll be much more like you'll have to multiply by about 9 things to get your answers. Okay, so they're just stoichiometry, but they have more steps. All right, so that's the 2 things that are new for today. So what is a radian? Who can tell me? What is a radian? Yes, sir. Yeah, you're close. I'm going to go with 57, but yes, 57 degrees. If you were to draw it, do you remember how we did it with the Skittles? We went 7 this way and 7 that way and then 7 that way, which meant this, and that were all the same. You know what I'm saying? It wasn't a 90-degree angle, though. It was about 57 degrees. So again, it was like that, where that, and that were all the same size. And these were radiuses, or radii, and this was an arc. Does that ring a bell? This angle right here, that was a radian when all 3 sides were equal. That made a radian. Now, do you remember that you couldn't, they weren't 60s, and so you couldn't just say that 3 of them would make a perfect 180. There was this leftover at the end here, like here's normal, and there was this leftover gap. Why? Because it takes 1, 2, 3.14 of them to get all the way to 180. 3.14 is the same as pi, so if you remembered nothing else from yesterday, I hope you remembered that when you get all the way to the other side, this is where 180 was, and it took pi radians to get there. So pi and 180 are in the same spot. Okay. Then we had you memorize a couple formulas. One was to get the number of degrees out of 360 times pi r squared would give you the area of, not a circle, a sector of a circle. Okay. And then there was another formula, S, I called it SOAR, but this technically isn't a 0, it's a theta. S equals theta r, and that was the formula for finding the arc. I really wish the S was an A, because then it would make more sense. A would stand for arc, but they use S. And it's maybe it's because it's a part of a sector of a circle, but a sector to me is the whole wedge. And that's what this formula is for. This formula does not give you a whole wedge. It just gives you this part right here. It's how long that little arc length is. Okay, let's see if you really remember enough about what we did yesterday. If that's 30 degrees, I want you to change it to radians so you can use this formula, S equals theta r, to tell me, remember this is the arc, the arc length, which is this little distance right there. Yes, your answer will have a pi in it if you're doing it right, because that way you're not estimating, you're giving me an exact answer. I'll pause for a second while you find the arc length. When the radius is 8 and the angle is 30 degrees. Somehow. All right. Okay. So this arc length here should be found by using theta, which is that. But you can't just throw a 30 in here. I hope you would be smart enough to go, wait a minute, 240. If this radius is 8, how could that be 240? That would be really dumb, right? That doesn't work. So you got to change this 30 degrees into radians. So what is it in radians? Well, I like to do it this way. 30 times pi over 180. If you keep talking, you will leave. These can simplify down, and I will recommend 30 times 6. That'll get me a total of 180, and then the 30s can cancel, and look at that, it's pi over 6. Pi over 6 times 8 is your answer. Raise your hand if you had that one right. All right, awesome. That is the sector length. Now, what about the area of this sector? Again, I said it wrong. That was the arc length that we just figured out. But what's the area of this whole piece? It's not a whole circle, obviously. It's a fraction of a circle. I'll pause for a moment while you try to give me that one. I'll pull this out to make it cleaner. Remember again that the radius was 8. I'll pause. We give that a shot. You don't have to simplify your answer all the way. Don't grab a calculator. Not worth it. We can't use calculators in this test anyway. Okay, hopefully you said it's 30 out of 360 of the circle. That's a fraction of the circle, right? It has degrees, but they're just going to cancel anyway. And then that's times by pi r squared, except I know r. R is 8. I'm going to just square it and say 64. And so, final answer, 30. I'm going to actually cancel the zeros. 3 over 36. Ooh, I can even reduce that. 3 over 36 is 1 over 12, I think. Pi times 64. And then I can ask myself, can I get the 64 broken up into 12 times something? I think it will. I think 6. Isn't 6 times 12? Nope. 5 times 12? Well, first of all, was I right to hear? I'm hearing mumbling and stuff. Okay, good. So it's just that I'm not reducing it right. Okay, so let me just get 2 out of there, because the 2 can go into both of them, right? This is going to be 32 times 2, and this is going to be 2 times 6. And then I'll cancel the 2's. And now it's 32 pi over 6. And then I'm just figuring out what goes into both of those. 2 times 3, and 2 times 18. Cancel, cancel. 16, thank you. So 16 pi over 3. I wouldn't have needed you to get that all the way down to there, but I knew somebody would, so I figured I'd finish it. How many of you actually got it all the way to there? Okay, cool. We wouldn't have anything. Well, actually, we could have something this tough on the test. And if you couldn't reduce it all the way, you would lose something. But we usually only take off like 5% if you can't reduce something. But hey, 5% off your test kind of sucks. So yeah, you'd want to simplify it all the way. So you couldn't just leave it as something up in here. Okay, so I'm feeling like you're understanding that. How many of you feel like you get yesterday's stuff? The sector length, or sectors, and arc length. Okay, good. Then let's move on. Here is the new stuff. You're going to be given a place, and you got to figure out where it is, like 7 pi over 6. Where the heck is 7 pi over 6? Well, first of all, you got to know where pi is. And I want to start by making a nice circle. Actually, let me get a really nice circle here. I'll use this and make it bigger from there. And then I'll start my angle. It always starts like that. There's always a line there. And then it's how far the angle opens up from there. Like for instance, if I open up to here, would you agree that's about a 45-degree angle? Because it's halfway to that, which would be a 90-degree angle. Okay, so that's about a 45. Okay, now that's also something in radians. You get all the way to here would be 180, and that's pi. That spot right there. It's really, really critical. I'm going to move this down a smidge so it matches up perfectly. There we go. Then that's halfway to pi, right? And that's halfway to halfway. which would make it pi over 4. If that's 1 pi over 4, where would 5 pi over 4 be? Would you draw the circle and draw where you think 5 pi over 4 is? Draw it. It's kind of like a clock, but only has one hand. You could argue it has two hands. The one that's always stays pointing at the 3, and the other hand that swings around. Well, if that's 1 pi over 4, that'd be 2 pi over 4, 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4, you should have been right there. Raise your hand if you had that one right. Okay, good. If that's 5 pi over 4, it's pretty easy to tell where 6 pi over 4 is then, right? Let's go another notch. 7 pi over 4? Everybody draw where you think 7 pi over 4 would be then. Well, that'd have been 6. And some of you are probably like, 6 pi over 4 doesn't sound right for that spot. Have you ever heard of 3 pi over 2? Because it's the same place, just reduced. And then 7 pi over 4 would be go one more notch. That'd be right there. Raise your hand if you had that one right. Okay, now would you agree that it would have been a lot quicker instead of going all the way around to here, we could have gone like this. It is a different angle, though. It's a way smaller angle, right? If you wanted to get to this spot, though, it would have been a lot quicker to do this negative angle. So 7 pi over 4 is the same as negative 1 pi over 4. Going down like that is negative. I'll give you another one. And I think this one might make a little bit more sense to you because I'm going to use degrees. Just make sure you get this whole negative angle stuff. Okay, say I had, that was 45, but say I got there a whole different way. Then it'd be negative 315. Starting here, say I just go down 30. To get that this could be called negative 30. Or I could have got to the same place by going all the way around this way, and then it'd be positive 330. There can be two names for the same spot. It's called coterminal. Terminal is where you stop. If the patient is terminal, their life is going to stop. Okay, that's where it stops. It's where it terminates. And these terminate in the same spot. Whether I had got here by going this way, or if I got here by going this way, they both are coterminal, it's called. Co means like the same. If you cohabitate with your family, you and your family are living in the same place. Okay, so co means same. So same terminate, same stopping place. All right, but there's actually two more names for this, and they are in radians. Do you get 30 degrees is actually the same as pi over 6? Have you got these memorized yet? Here's a way to think of it. Would you agree that pi is 180? Remember, pi is 180 is over here. 180 is pi. They're the same thing. One's in radians, one's in degrees. So this is like 180 divided by 6, which is 30. Does that help you see that pi over 6 is 30? Because pi is like 180. All right, so that means that spot right there is at negative pi over 6. Because it's down this way 30 degrees, and 30 degrees is really pi over 6. So it's negative pi over 6. And one last name for this spot, there's 4 names, is to go all the way around, the big way, all the way around this way and stop at that spot. And you would have gone a whole bunch of pi over 6s. Specifically, how many? 6 pi over 6 or more? 6 pi over 6 was right here. So a lot more than 6 pi over 6. 11 pi over 6. Now I know, that's a lot to get your head around, but there's 4 names for that spot. All right, so what I want you to do is draw a circle for me. And I want you to tell me where 11 pi over 6, no, that was the one we just did, 8 pi, no, 6, 5 pi over 3 is, and what are the other names for it? Where's 5 pi over 3, and what are the other names for it? Think of it like a clock face. One of the angles is always pointing at, or one of the sides is always pointing at 3. You always have that. But where's the other one? 5 pi over 3. And then there's other names for 5 pi over 3. Quite a few of them, actually. Is it there? No. But that's kind of close to where 1 pi over 3 would be. And this is like 2 pi over 3. And this is like 3 pi over 3. You get where I'm going with this? And 4 pi over 3. And 5 pi over 3. Exactly where is that? Well, I'm not sure, but pi over 3's, I know because I can do this in my head really quick, is like 180 divided by 3. Pi over 3's are like 60s. Do you get that? We just went a bunch of chunks of 60. That's like 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. 5 sets of 60. Do you get 5 times 60 is 300? 5 sets of 60 is what we just did. If every pi over 3 is 60 and we did 5 of them, then it's 5 times 60 is 300. Raise your hand if you had 300 degrees for that spot. Good. And then if I wanted to go the other way, I would have, well, it's the rest of it would make it up to 360, right? So this must be a 60. But if you go from here down, negative 60. And last, there's one more name for it. A negative, but radians. What do you think? Yep, negative pi over 3. They all end in the same spot. Those are the 4 names for that spot. All right. So now, let's just do one more, and this time I want you to draw the clock face. It's going to always start with that. It's always got a line pointed at 3. Do that now, and then tell me where would 16 pi over 3 be? 16 pi over 3. That's about as nasty as you can get. But just think of it as 16 pi over 3's. So figure out how big a pi over 3 is and just count it out. 1 pi over 3, 2 pi over 3, 3 pi over 3. Maybe you can start going, oh, actually 6 pi over 3 would be once around. Do this. Don't just look at the board. I asked you to draw a circle. A little arrow pointing at 3. Okay, so here's how hopefully your thinking process was going. That's like about 1 pi over 3, 2 pi over 3, or you could even start it with that, which is 3 pi over 3, right? Because 3 pi over 3 is the same as pi. 4, 5, 6 pi over 3, 7, 8, 9 pi over 3, 10, 11, 12 pi over 3, 13, 14, 15 pi over 3, 16 pi over 3. Raise your hand if you had approximately there, or maybe a little further, like there-ish. Raise your hand if you had that one right. Okay, good. Give me just one other name for it then. I'd pick this one for me. But negative is for sure right. Would you agree it's a bunch of pi over 3's? So how many pi over 3's do you have to go to get there? Negative 2 pi over 3's. Yes, sir. Okay, if you want it in degrees, then this would be 180 plus, would you agree from here to here, it's another 60 degrees. These are 60-degree chunks. So 180 plus the 60 would be 240. Yep. Depends. You can make it go further. The point is just, think of it this way. Think of this as a place you want to get. And there's a lot of ways to get there. You can go around 23 times and then stop there. That works. You can just go half, like go all the way around to there and you stop there. You can go from backwards and stop there this way. So all of these are coterminal. They're equal. So here's one more that might answer your question just differently. Let's say I had 30. Do you get a 30-degree angle would be right here? Is that the same exact spot as 390 degrees? Yes, it is. So is 30 the same as 390? Yeah, actually, they bring you to the same spot. They're coterminal. They're not the same, but they bring you to the same spot. Okay. Or I could go this way and get there and say, let me think, it's up 30, so that'd be negative 330. That's another way to say the spot. They all get to the same, they're all different ways to get there. Okay, so that's the main new thing for today. Now the last part is stoichiometry. I want to give you a really easy one. Let's say I can run 25 feet in 2 seconds. That'd be really fast. Okay, how fast is it in miles per hour? Multiply by a bunch of things. And don't actually grab your calculator and multiply it. I just want you to write out the fractions that you'd multiply by to get this into miles per hour. And we'll see how well you learned this in science. If I want miles per hour, I got to look at this stuff and say, what do I have to change? Well, I have to change both. So if feet has to change, I'm going to put feet here. Now I got to have something with feet. What do you think?
I mean, 500.
There you go. Yes, excellent. Now my feet have canceled. I've got miles per second. I'm close. Go ahead, you can finish it off. 1 sec is, that's not working so good. Maybe I should do it. There you go. 1 min. Cancels, and now I've got miles per minute. So one last one. Minutes. Now I have miles per hour. That's it. Now, how do we make this from science into trig? Just because it's in a circle, and we're going to not start with like feet per second. We're going to start with something called rotations. Have you heard of RPMs? That'd be rotations per minute. Okay. Well, then if I have a bike tire and it's going around 100 rotations per minute, the question is, how far, or I should say it this way, how fast really is that? Well, so far I only have I have rotations per minute, but I don't have a distance because I don't know how far a rotation is, right? So that's the key. To get this into miles per hour, you know how I get minutes to hours, that'll be easy. But how do you get rotations into miles? What do you need to ask me? Yes, sir. How much distance is one rotation? And we will never tell you that. But we'll tell you something. What do you think we could tell you that'd be easy? The radius or the diameter of the bike tire. So here's my bike tire. And let's say my bike tire is 30 inches across. That'd be a pretty big one, but let's say it was. So this is a nice round number. Would you agree I got to multiply by something with rotations down here? And here's the one I would recommend because I think it's the easiest. One rotation is the same as 1 circumference. Would you agree with that? Then the rotations cancel and I got to get rid of circumference. 1 circumference, there we go. 1 circumference is equal to what? Well, do you know that formula? Circumference equals it, 2 pi r. And then my radius in this case, if it was a diameter of 30, what's my radius? 15, and then I can just go 15 times 2, and because this formula also can be pi times diameter. It's going to do the same thing. So, bottom line, the circumference is pi times 30. And that's in inches. You get, I got rid of circumference now, and now I have inches, and now I got to get inches into miles. So there's a whole bunch left to do, but it's now inches per minute, which is basically 2 extra steps over what a typical stoichiometry question has. So you end up having to multiply, I don't know, you tell me if you do ones that have like 6 steps, but we typically have like 6 things you got to multiply by to get it to the end. What is a typical science one? Like 2 or 3, or like 3 things? Okay, 3, 4 maybe. We have like 6. And it's not like it's so much harder. It's just this rotation's changing into a distance thing. Just remember, a rotation is a circumference, and you have a formula for circumference. Circumference is pi times diameter, and we'll always either give you the radius or the diameter. So it's really not that hard. You just throw in an extra step. This part right here. All right, so let's do one, and I don't need you to even multiply them. I just need to know that you can know what the fractions are. Okay? So here is a typical one. Let's say that I am watching this little kid ride his trike, and I'm really bored. And so I count. He's got like a little reflector on his bike tire, so I can see how many times it goes around. You know, like. And so let's say in 2 seconds, it goes around 3 times. Okay, so 3 rotations per second. Now, as I'm, what? Did I say 2 seconds? Sorry. Thank you. 3 rotations in 2 seconds. Okay, good. Now, what else do I have to tell you to be able to figure out how fast this little kid's going? I need the radius of the diameter. Good. If you're thinking about a typical trike, and I was looking at the front tire, I'm going to say it's about 1 foot in diameter, and that's going to make it work pretty nice too with your stoichiometry. 1 foot diameter. Okay, how fast was the little kid going would be the question, in miles per hour. So the stumper part is always getting rid of rotations. So try to do that first. What is a rotation, really? A circumference. So set it up for me. There should be, like, literally, I think there's going to be 6 things you are going to multiply by. Maybe not 6. Maybe it's 5. Maybe it's 7. I don't know. You want miles per hour when it's all done. Yes. I'll pause for a second. Okay. Let's see. GT. How did you start? Perfect. Rotations are gone, but now you got circumferences. What's 1 circumference? Equal to what? 12 minutes left. Excellent. What is the circumference? Do you remember that formula? Circumference is 2 pi r, or even better, circumference is pi times diameter. So, what is the circumference? What did I put on top there? Pi times the diameter, which is 1. So 1 pi, but it's in feet. Excellent. And now circumference is gone. Always cancel them as you go. And then I got feet per second. Am I done? No. Got to change feet to miles. Feet go down here. 5280, 1 mile. Then I got feet out of there, and I got miles per second. Am I done? No. I got to get the seconds out of there, so I'm putting seconds here. What's a fact we know about seconds? 60 seconds is what? 1 minute. Now I have seconds cancels. Now I got miles per minute. Got to get hours somehow, so multiply by how many, what, where? 60 min, 1 hour, minutes is gone. I guess we got 1, 2, 3, 4, 5 things we multiplied by this time. You get that? If you've never been good at that before, you got to get it now, because it's definitely something you have to know. All right, so your typical question on that, there's 2 word problems tonight. We'll always tell you the radius of the diameter, and that gives you the circumference. And the circumference is really a rotation. One more word, revolution. That's the same as a rotation. Get that? All right, so then you have 2 word problems like that, and then a bunch of these. Let's just do one last one to make sure you get this. I said you'd be able to do this by the end of the hour, and I hope you can. Can you tell me, if you always have one going this way, where would this be? 7 pi over 6. Where is 7 pi over 6 pointed? Turn it my way and I'll tell you. And be careful, like don't just go, oh, I think it's over here. Like be specific about like where do you think that angle is? 7 pi over 6. I don't think so. I would agree with that one. Yep. Yep, 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 yep. A little bit too far, actually. I think that looks more like you went 45 past. It actually matters. Yep. You went a little too far, I think, again. Just did it quick or something. You should be going just past 180. Yep, 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 yep. Tilt it a little bit. I can't tell what that says. Would you ask the kid next to you? Yes, 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 yes. All right. It's not 120, though. Okay. 7 pi over 6 is how many pi over 6s? 7 pi over 6s. That's the way I want you to think. 1 pi over 6 is like that, which is like 30. 6 pi over 6 would be like that, and it's 1 past that. So then 7 pi over 6 is like this. I was ripping on the people who had theirs like this, because that's not, this angle that's left here was way too big. You needed it to be, so it was just a little more. In fact, how much more? What would that angle right there be? 30, very good. Because these are all little wedges of 30. Okay, so final answer, that spot right there is 180 plus 30, I would agree, 210 would be a way to say it in degrees, or negative I think it's 60? No, 150. Negative 150. Or negative something in radians. A bunch of pi over 6s. Negative 5 pi over 6. Those are all the same spot. Because negative 6 pi over 6 should be there. So it's one less than that, negative 5 pi over 6. Okay. That's the stuff you're supposed to know for today. And now let's look at your homework together. I'll pause when we get there. So here we are. On this page, it asks you what quadrant you're in, and it says it in a complicated way. Classify each angle according to where its terminal side lies. I just want you to draw it for me. You know where 330 is? That's the original starting. Where would 330 be? It's there. That's 330. And then it asks you to give 2 more answers. I want one of them to always be the other thing. If they gave you degrees, I want you to give me one in radians. This is going to allow you to skip a whole page. It's going to skip like 12 questions. So just make one of your 2 answers, one positive and one negative, make one of them radians. Okay, so give me one that's negative in degrees. That's a pretty easy one. That'd be like negative 30. What's another way to get there except in radians? Well, 30 is the same as pi over 6. So I could say it's negative pi over 6. Last option you could have used, is a whole bunch of pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9, 10, 11 pi over 6s. And I notice I didn't go all the way to 12 pi over 6 because that would have been 2 pi. That would have been here. All right. I gave a little overkill. I gave three answers, but anyway, you have to give 2 of those 3 possible answers, and one of them needs to be in radians. And if they give you in radians, you have to find it and then give me one answer that's in degrees. Then you can skip this whole page over here. Okay, so cross this one off. And I hope you know which quadrant's over which, but I'm going to make that a separate issue. You do not have to tell me what quadrant it's in. But if I had one that's in this quadrant, do you guys know that that's quadrant 3? Does that ring a bell? Okay, because this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. If you don't have those memorized, you need to know them, because they're going to sometimes do that on the trig test. They'll say, this angle is in quadrant 4. You have to know, oh, it must be somewhere in here then. Okay, so there's a few more you can skip. Besides this whole page being skipped, we're going to do this one, and we're going to do that one. Those are the 2 stoichiometry kind. This one you may skip. It's a good question and everything. We just had too many today. And this, again, I don't think you need this much review. We can cross off this whole left one and the whole right one. We'll just do the middle one, number 61. One review question. Crossing these off? You're going to want to know what to do later. Then we get to this one. Skip. Okay. That's your homework for tonight. Remember, I just cut out a ton of problems. Your job is to actually do all the ones I left you with. It's got to go both ways. If people are going to be like, I didn't do my homework last night. If you do that a lot, I'm going to just start assigning them all. Okay? Because it's a lot simpler for me. I would rather, though, be smart about narrowing it down for you and have you be really good about getting it done. But that's a big deal. I get you're going to have an occasional night when you just can't get it done because you got too much. I've seen it in my own kids' lives. It happens sometimes. Just get this confluence of a ton of assignments. But don't do your math second semester. In about 3 weeks, you'll be so far behind that you will never catch up. This is tough. And one day at a time, it's not that bad. It's kind of like eating an elephant. You have to eat it one bite at a time. You can't wait and then have to eat like the whole elephant leg in one night. You won't be able to do it. One little bit at a time. All right, that's all I got for you for today. Change later.